In our previous videos, we explored how an LLM can suggest tools and how we can execute those tools manually. But what if we want the model to actually carry out a multi-step workflow, handle immediate results, and inject critical information into subsequent tool calls automatically? And that's where the concept of injected tools comes in. And it's what we're exploring in this video. So imagine the LLM as a helpful assistant with access to a set of tools, like a calculator or a currency converter. When you ask it a question, it might realize that to answer fully, it needs to use more than one tool in a sequence. For example, if you ask like what is the conversion factor between USD and NPR, and based on that, can you convert 10 USD to NPR, the assistant first needs to fetch the conversion rate and then apply that rate to the value you want to convert. The magic happens through injected tools arguments. This tool allows the LLM to recognize that some tools require additional input, like the conversion rate for this case, which might not be explicitly provided by the user, but is generated by a previous tool call. Essentially, it allows the LLM to remember and pass context between tool executions automatically. And here's how the workflow unfolds. First of all, we start with the LLM call. So we send the user's query to the LLM bound with tools. The LLM analyzes the query and chooses which tools need to be executed. For instance, it first calls the get conversion factor tool and then plans to call the convert tool. The second is the multi-turn tool execution loop. Here, the code then executes each suggested tool. When the LLM calls convert, it might not know the exact conversion rate yet. This is where the injected argument comes into play. Uh, the program automatically injects the conversion rate obtained from the previous tool call, ensuring the tool has all the information it needs. And the final is the feedback or feeding results back to the LLM. So after each tool execution, the result is packaged into a tool message and then sent back to the LLM. The LLM then uses these output to generate the upcoming step or finalize its response. The loop continues until LLM produces a final human readable answer in the content field. So this approach is powerful because it transforms the LLM from a simple chat model into a true agentic system. It can now plan, execute, and chain multiple operations together while intelligently handling dependencies between them. So in this video, we will walk through a live implementation of this workflow. We'll see the LLM first retrieve the conversion rate and then use it to convert a currency amount and finally produce a complete readable answer for the user all automatically. So this pattern is not only limited to currency conversion, it's a blueprint for like building multi-step AI agents that can handle complex tasks with multiple tools and dependencies. Now let's move on to the implementation. So I'm going to create a new file here, call it test multiple tool call.py. Okay, so inside this, first of all, the imports. First import tool. After that, import tool message as well as human message. Then load the model. Then our .env. Here from inside LangChain to LangChain code .tools, I'm also going to add InjectedToolArg, and then last one from typing, I'm going to import annotated. Okay, so first of all, load the credentials. Then I'm going to define a tool here. So this tool will be get conversion rate. It will contain two strings. One is base currency. It will be a string, and then the other is target currency. it also be a string, and then it will basically return a float value. So write something in the doc string, return the real-time currency conversion conversion rate from base currency to target currency using some API. And here I'm actually not going to call the API, but I'm directly going to use this static conversion rate. Let's say 140.3. Okay. And then I'm going to return this conversion rate from this tool. Next, I'm going to create another tool here that is going to be named as convert. Here I will have a base currency value, which will be in float, and then I'll have a conversion rate which will also be in float, but it will be annotated, and then float and injected tool arg. Basically, first of all, the value will come from the other tool to this particular tool here, and then it will also return a float value. Write a doc string, converts a base currency value into target currency value using a conversion rate. Okay, so this is going to return base currency value into conversion rate. Now we will set up LLM. So LLM equal to chat Google generative AI. The model is going to be Gemini 2.5 flash model. Then what I'm going to do is I'm going to bind these tools. So LLM with tools equals to LLM dot bind tools. The first tool is get conversion rate, and then the second tool is convert. Now I'm going to pass in my query. So my query is going to be, what is the conversion factor between USD and NPR, and based on it, can you convert 10 USD to NPR? Okay, so this is going to be my query here. Now, what I'm going to do is I'm going to include this query as a human message where the content is going to be query, and I'm going to wrap this up in a list itself. Okay, so let me invoke the tool and then get the AI message from this. So LLM with tools dot invoke messages, and then whatever I get, I'm going to append it in the messages itself. So append AI underscore message. Okay, now in step 2, we go for multi-turn tool execution loop. So while AI underscore message dot content equals to an empty string, and AI underscore message dot tool calls. So if something is present in the tool calls, what I'm going to do is I am going to create a list of tool messages, and then based on this, I'm going to execute all suggested tool. So for tool call in AI underscore message dot tool calls, I'll first call in the tool name, which is going to come from tool call name. I will also try to get its ID, So tool id equals to tool call id, and then I'll get the arguments. So ToolArgs equals to tool call uh, and then args here. Okay, so let me print every tool that I've got. So executing tool, and here will be my tool name with args, and then here will be my tool args. So this will be made as an f string here. Okay, this will be, or I can just do this, and then this is going to be my f string. So now if the tool name is equals to get conversion rate, then I'll invoke that function here, dot invoke, or invoke that tool, and then I'll get the tool output in the form of a string, and then that will be my conversion rate. So else, if the tool name is equals to convert, so if the tool name is directly convert, then what we need to do is we need to first inject the conversion rate from the previous result step. So if conversion rate not in tool underscore args, ensure the conversion rate is actually defined from the get conversion factor run. So if uh, conversion rate not in locals, or conversion rate is none, then what we need to do is we need to raise a value error saying that conversion rate is required but is not found. Else what we need to do, we need to get the conversion rate from tool args, conversion underscore rate equal to conversion rate. And then based on this, I need to execute my tools. So converted value equals to convert dot invoke tool args, and then tool output can be converted to a string value using str function. Okay, if none of this is possible, we'll do tool output equals to unknown tool, and then we'll say tool underscore name. Okay, most of our work is done. What we need to do is now we need to, since every condition returns a tool message to us, so what we're going to do is we're going to create a tool message. It will be wrapped inside this tool message here. The content is going to be tool output, and then the tool call id will come from the tool id. And I'm going to append tool messages dot append tool message tool underscore msg, and then now I'm going to append everything to our messages here. So still, I mean, I am supposed to be inside this loop here. Okay, I think I did some mistake here. So this has to go inside the while loop. inside inside the while loop. And then now what I'm going to do is I'm going to messages dot extend or append. You can use anything, tool messages. Then I'll again prompt for AI message and then invoke the model with the updated messages, and then I'm again going to append it in my AI message. Okay, so finally we already should have obtained our result inside this particular part here. So what I'm going to do is I'm going to take out the last result. So messages -1 -1, and then I'm going to print the final result dot content. So let's see. My query is, what is the conversion factor between USD and NPR, and based on it, can you convert it from 10 USD to NPR? So if you run this, let's see what happens. So the model is called, the model is initialized. The conversion rate between USD and NPR is 140.3. This is done using this get conversion rate tool. And then from that, after that, we call this convert tool with the base currency value of 10. And then the exchange rate or the conversion rate of 140.3, and then 10 USD is equivalent to 1403 NPR. So this is the result. So here we've not only integrated multiple LLMs multiple tools into an LLM, but we've also used this concept of injected tool, where the result of the previous tool will be the input for the upcoming tool. So I hope you understand the concept of injected tool, and then you had fun implementing this particular code here. If you have any problem, do comment down below and I'll try to help you out. And in the next few videos, we're going to see AI agents demo using LangChain. So we are almost at the end of this LangChain series here. Within 1 or 2 videos, we're going to conclude this, and then we'll gradually move on to LangGraph. So I'm going to end this video now. I'll see you in the next video.